I am Mohammed Nawaz from CSC department from BVRIT in Sapur. Now I am going to explain the reliability design from the DAP subject. DA stands for the design analysis of algorithm. Let's go with the reliability design. In the reliability design, it is defined as what is meant by reliability. Actually, the probability of working condition of the device is called as reliability design. The working condition of the device. Suppose let us take this mobile. So the working condition of this mobile is can be described by the reliability in the terms of reliability. Design a system with high reliability and construct with low cost is very important to design anything which we depends on the performance of the condition of the devices. So now let us take this example. Let us d1 d2 d3 are the devices up to dn, n devices where di where I goes from the 1 to n connected in series connection. Suppose its d1 is not working, then its effects also affects in the dn, and dn also will not work. Okay, going to the next slide. This is the multiple devices connected in the parallel way. Suppose d1, it's a copy of d1. Suppose we will take the keyboard. The keyboard can be connected, many keyboards are connected to the single devices, such type of thing which is in parallel connection, but does not affect in this. But these all are connected in the series. Next, let ri be the reliability of devices, di then the reliability of the entire system is pi ri. The reliability of the entire system is pi ri. Let us see one example, not an example. Let's describe more about this. Let mi be the copies of the devices, mi the number of copies we want to design. Then 1 minus ri. What is ri? Ri is the reliability of the devices of di. Be the probability that all mi have a malfunction, hence the stage reliability is 1 minus 1 of 1 minus ri whole power mi. We will denote the reliability stage is by phi I of mi. Then phi of mi equals to 1 minus of 1 minus ri of whole power mi. In reliability design, we will get maximize reliability using device duplication. That means minimize reliability pi, where 1 less than or equal to I less than or equal to n, where I is from the 1 to n pi I of mi, subject to sigma of 1 less than or equal to I less than or equal to n ci mi. Ci is a cost, and less than or equal to c, this is the total cost, maximum allowed cost, and cost of each device is I, ci. In the dynamic programming, solution for this problem is similar to 0.1 naps of problem. Here we assume ci is greater than 0 and mi must be the range from 1 less than or equal to mi less than or equal to ui, where there is the formula for calculating the ui. U is the upper value, and c is the actual cost, and ci is the cost of the dead device, and c of j will how many devices are connected by ci. In dynamic programming solution, si consists of the tuples of the form of f comma x, that is reliability cost. In this tuple is in the where reliability is f and x is the cost, where f equal to fi of x. The fi of x can be computed as the fi of x equal to a maximum of 1 less than or equal to mi less than or equal to ui. This is the formula for the fi of x. Initially f naught x is equals to 1. Dominant role. What is meant by dominant role? f1 comma xi dominates the f2 comma x2 if f1 is greater than or equal to f2 and xi is less than or equal to it. I explained it normally, where the tuple of the first one should be in ascending order than the second, then it will be used. Otherwise, if the first one is more value, then it will be cancelled out. discarded from the SI. As you can see, XI less than or equal to. Now let's see one question. Design a three-stage system with devices types D1, D2, D3. The costs are rupees 30, 15, 20 respectively. The cost of the system is to be no more than the final cost should be the 105. There should be no acceleration of the cost. The reliability of the each device type is 0.9, 0.8 and 0.5 respectively. The reliability is already given and the cost is already given of the each device and the maximum cost is 105. Let's find the reliability of entire system. Devices types D1, D2, D3. C1 cost is 30, C2 cost is 15 and C3 cost is 20. Maximum allowable cost for the system is 105 and the reliability is given. Now we have to find the M1, M2, M3, which is how many copies of that values to get the solution for this problem. First compute the U1, U2, U3 values using the following formula. The formula you already know, the upper formula, and first in the first case we'll find the U1, which is the upper of the one. The cost of the first device is 30. Total device plus computation of the all devices, total sum by will get 70 by 30. That is approximately equals to 2, and from the U2 we'll find this, and U3 will also get the 3. We get the U2, U3 is the similar, and this is the U1 upper boundaries. Now we will start computing the subsequences we have already learned as the tuples f naught of x comma x naught s power first initially for the s power 0 and their value is the 1 and comma x naught is cost value is the 0. We can obtain each SI by typing out all the possible values for mi and combining the resulting tuples together. Okay, first one, that's s1 of 1. 1 is the m1 value. Include the first tuple, the reliability cost is 0.9 and 30. Okay, by the 5m value, 5 of m1 value, 1 minus 1 minus r1 of whole power m1. M1, what is the m1 value given is here is a 2. Okay, the whole power on will be this, but we need to multiply with the previous one. 30 into 2 is 60 and 0.99 0.99 into 1. In the first one we got the 1 as a tuple, so there is no changes. Combine the tuples, the s1 and s2 is the 0.9 and comma 30 and 0.99 comma 60. To compute s power 2 we need to s1 square, s2 square and s3 square. U2 equal to 3 and s1 of square is by this, and we'll need to multiply with the previous one. Okay, the previous one is 0.8 as we get here. 0.8 is that one and 0.9 is the previous one. We'll get the calculator as follows, and we'll get the 0.8 as 15 into 1 as the first one and the 15, and we'll get the addition of the previous one, the 60 plus 15 for the s1 square, and 0.792 is 75 and 45. This is the tuple we got, and now we'll compute the s2 of the 2, which is the we need to multiply with the same with the previous one. Okay, the 2 and 30 where m2 equal to 2 and the whole square, and here we got the computed value with the tuples 0.9 into 0.96. Let's go back and see where is the 0.96 we got here. Sorry, 0.96 is the value of the let me check. We have multiplied with 0.9. Yeah, we got here that this is the previous one, so we are multiplying with this, and we have added the 30 to the previous one. Here the 30 and the previous one is the 30 we'll have added, and now the final will be the 0.99. If we keep in the ascending order, this 2 is the 8641 is lesser than the 9504, and we'll go for the third m1 value, the multiple devices, and here the 3 of the square will get 0.992 and 15 into 3, 3 is the previous value. We have multiplied and we'll get this s3 2 of square 0.8928 comma 75, and obtained from the 0.99 60. Here the 98208 105. Here we are exceeding, about double exceeds the cost of the 100%, hence we will not consider this, we will cross out this. And we'll go further and we'll get this in the ascending order further. Due to the dominant role is here we got the reason for the 0.792. Here we can see 75 75 is both are equal, so we will remove the first one, 0.792 by the dominant role. We can also eliminate 0.9540 pair because it's a compute values for S3 using the banana exit. In the next step we'll exit this 105, so we also eliminate that. The final output for the final tuple is this, and now we will compute this s1 s2 s3 using the pairs. Okay, by the finally we'll get that in this way and calculated using the by the previous one multiplied and added for the cost, and I equal to 3, j equal to 2, m3 equal to 2, and here the final pi I mi, and we'll get the 40, and the first tuple is calculated as this, and the second tuple is next tuple is calculated as this, and third this we can see there is no extradition from there. So in this it's exceeding 75 plus 40, not 5, it's exceeding in it, so we'll eliminate the next, we'll compute the 0.75. Here 60 will add and exit, the cost will exceed 100%, so we need to compute this 3 tuples. Due to the dominant role, tuple is also eliminated. Why this is eliminated is the 95 is exceeding. If we add in the next one, will exceed 105. Sorry, here c3 m3 equal to 60, we'll add to the in tuple and the cost will be exceeded. So due to the determined dominant role, the final now consider the tuple with 100% mij. This is the obtained from the s square and my equal to mj. We know compute, we have computed them by using the 0.86460. The tuple is present in the s2 of square, that is I equal to 2, j equal to 2, and m2 equal to 2. Okay, the tuple is computed by using the 0.9 comma 3 30. This tuple is represented as the say 3 m1 equal to 1. So with the final values is the m1 equal to 1, m2 equal to 2, m3 equal to 2. The solution of the reliability design is m1 equal to 1, m2 equal to 2, and m3 equal to 2. So any doubts in this presentation can be revised by these previous PPTs, and you can also pause the video and try to solve by this by step in it. Thank you. That's my time. Thank you.